Hi, welcome to Moose Chemistry. This is VESPR Models Lesson 1. In this lesson, we're going to look at this chart showing different formula models and shapes and how they relate to each other. Okay, let's take our first compound. We're going to look at a nitrate ion, which is going to be NO3-. Okay, first thing we need to do is figure out how many electrons does each element bring in. So 1 times 5 electrons. Well, how did I know that nitrogen brought in 5 electrons? Well, nitrogen is in group 15, right? So all I do is get rid of the 1 and it tells me 5. Oxygen, I've got 3 of them. So oxygen is in group 16. So I just get rid of the 1 there. Okay, so that'd be times 6 electrons. Now, notice that I have a minus charge right there. That minus charge means I'm going to add an electron to this count. So this is going to give me 5 electrons. 3 times 6 is 18 electrons. And then I'm going to add 1 more electron to the count. So this is going to give me a total of 24 electrons. So whatever I draw, I have to have 24 electrons. Okay, that's great. Now let's go ahead and let's set up nitrogen and oxygen. First of all, let's see which one has more docking ports. Nitrogen has 3 docking ports. What do I call a docking port? These unshared electrons right here. These unshared electrons, docking ports. Oxygen, on the other hand, has a total of 2 docking ports. So that makes nitrogen our core atom. So we'll go ahead and erase some stuff here. Give us some space because these charts are both taking up an incredible amount of space. So remember that we are using 24 electrons. Okay, so now let's go ahead and draw nitrogen, our core, and then we're going to put oxygen around all 3 of these. And then it tells us that we have to connect our nitrogens. And then we're going to put in our remaining electrons right here around our wraparound atoms. And let's see what we get with this. Okay, now we've got 8 times 3 is 24. This gives us 26 electrons, it looks like. So you know that this is not right. Right, that's way too many electrons. So let's go and let's see if we can't fix this. All right, so how would I go about fixing this? Well, the first thing I'm going to do is I'm going to take these 2 unshared pair electrons, right? And we're going to remove them. We're not getting rid of them off the atom, but we're going to add them down here. And we're going to make a new bond between this oxygen right here. But we can't violate oxygen's octet, so we need to get rid of these electrons and then reshape this in here. Draw it. And so now I have this situation. So let's count our electrons now. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Oh, so we've got 24 electrons. That's perfect. Now, let's look at our structure. We have A for our core, X for this oxygen, X for this oxygen, and X for this oxygen. This is X1, this would be X2, this would be X3. You can name them in reverse order if you wanted to. So this is AX3. Well, an AX3 model is right, let's find it. It's right here. And it's called a trigonal planar. Interesting. However, we're making it look more like a T, so we need to actually fix that drawing. So let's go ahead and fix the drawing. And we're going to make nitrogen, again, our core. And we're going to have an oxygen splitting off on either end. Like that. We'll put our double oxygen right here. Because see, electrons don't like each other. And so we want to make sure that they respect each other's distances. Okay, look at that. That's looking pretty good there. But this brings up another question. How do we know that the double bond goes here? Why can't the double bond go there or there? And it can. So actually, we're going to have to make 3 drawings. So let's go ahead and erase all this again. And this time, let's make 3 drawings. All right, so we're going to do our first drawing. And we're going to put what we used to have in there. So we're going to make this small. And because this is NO3, you have a radical. So you're going to need a radical right there. Let's draw our first N. There we go. First one in. Doesn't have to be perfect. Just make sure you denote it. Okay, then we're going to do this one. So in this time, this is going to be O. This is going to be O. And this is going to be our double bond this time. Or, we used to say that the double bond is not right here. Not on this side. Snarls, huh? And then of course we're going to close it all off. Let's get rid of that AX3 because it's now in the way there. And we're going to make this a -1 charge. So now, guess what? We have something called a resonating structure. So there are 3 possible drawings here. There's also something called formal charge. If you really wanted to double check to make sure that this is the best possible structure, there's a way to do it, and we use something called formal charge. So let me go ahead and put that in here. So let's do formal charge. Formal charge equals valence electrons minus bonding electrons minus non-bonding electrons. Okay, so let's do the formal charge of nitrogen first. So nitrogen came in with 5 valence electrons. Bonding wise, 1, 2, 3, 4. It's got 4, right? Okay. And then let's see, it's got 4 there, and non-bonding is 0. So you're going to have a +1 there. Okay. That in itself is not a good sign, but these oxygens, I believe, are going to be up forward. So let's look at the formal charge of oxygen. Now, there are 2 different sets of oxygen here. So one has a double bond, the other one has a single bond. So we're going to call this oxygen 1. We'll do the double bond first. So oxygen comes in with 6 valence electrons. Bonding pairs, we have 2. And non-bonding electrons, we have 4. So that double bonded guy is a 0. That's good. So the formal charge of our second oxygen is going to be, oxygen comes in with 6 valence electrons. Bonding pairs, it has 1. And non-bonding electrons, it has 6. So this gives us -1. And we have 2 of these. We have 1 right here, and we have 1 right there, right? So that's going to give us 2 negatives, so it's times 2. So this positive right here in the core would be +1 minus 2, give us -1. And that's why we get our negative charge right here. Well, that's it for this lesson. You guys be snarling, and we'll see you back here at Musin Chemistry.